Welcome to our first problem, is unique. The goal here is to write a function that'll take in a string and determine whether each character in that string appears only once. Essentially, we're trying to see if each character in the string is unique in that string. We want it case sensitive, meaning both lowercase and capital versions of a letter in the same string are considered unique. Here's some examples. We get a normal string A, B, C, D, E, F, and everything's unique, so we want the function to return true. This next example just shows that we want our function to be able to accept a string with any type of character, not just letters. Again, they're all unique, so we get true. This third example again shows that a lowercase a and a capital A in the same string we would still want our function to return true for that input. The fourth one shows a duplicate lowercase a, and our function would return false. Let's just go ahead and start writing this function right away. So, to make sure every character in our string is unique, we're going to need to process every character in the string. So we know we're going to need a loop. Let's go ahead and start there. What do we want to do in this loop? Well, one strategy we can employ is the following. Our loop here is going to go through a string left to right. So taking this as example, we're going to start at A. What we can do is we can have another loop going from right to left, looking for that same character. So while our outer loop is on A, we can have an inner loop going from right to left, also looking for A. If it finds it, and it's not in the same position that the outer loop is at, we know that we have a duplicate, and we can immediately return false. If there's no duplicate, this will run all the way until it gets to the A over here, and we know that it's unique in the string. We can repeat this going left to right as our second loop goes right to left for each individual case. This might seem complicated, but there's a little method that makes this very simple for us. Let's write it out and discuss it right after. Last index of. This will do exactly what I was just describing. It'll go through the string right to left, looking for the character we provide. In this case, whatever character that I is currently on. So again, we give it A, in this case, for the very first round, and it's going to go right through left, looking for A. So what we're doing is making sure that the last index of A is the same as the current index that we're on. This will show that the character is not duplicated in the string. If, however, the last index of A is not the same as the first index of A, then we can immediately return false. That's really all the logic we need. At the end of the function, we can return true. It'll only get here after it's processed every character here and made sure that there's no duplicates. This function will work. Let's go ahead and run our code here, and we expect to see true, 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 false. And that's exactly what we see up here. So our function works correctly. Let's go through the time complexity of this function. So we can see that we have a for loop, and that immediately brings our time complexity to O of n, because every single character is being processed. Right here, we actually have another loop in the form of last index of. While it's not a loop that we wrote, it is a loop that is going through the string from right to left. So this is actually another O of n. Since this is nested inside the outer loop, we need to multiply these time complexities to give a final time complexity of O of n times n, or O of n squared. What's the space complexity? Well, let's think about it. No matter how long the string is, whether it's 3 characters or 30 or 300, we're only ever using one variable in our entire function, and that is I. We're only storing one character at a time. No matter how large our input is, our function takes up the same tiny amount of space. So we say that it uses constant space, or O of 1. That's it for this version of the solution. Can we improve the time complexity a little bit? Yes, we can. Let's go ahead and try that. There's something we can do before we go through our string to make it a little simpler. We can sort our string. So let's go ahead and try that. So what I've done so far here is I'm taking the string and splitting it into an array. That's what this method .split does with an empty string right here. So at this point, cars would just be equal to an array of individual characters. In the same line, we can sort it. The characters will now all be sorted from left to right. So if we were given something like DBAC, it would look like it would have an array. It would now be an array of A, B, C, and D. Simple as that. What can we do now that our characters are sorted? Well, there's a different piece of logic we can apply to make this a lot easier. We're going to need the standard for loop again. Actually, I is going to start at 1 for this one, and we'll explain why in a second. So now that the characters are sorted individually, if there are duplicates, they're going to be placed right next to each other. Again, assuming we got DBACA, this will now turn into AABCD. The two duplicates appear right next to each other. So what we want to do is, for this string, or rather this array of characters, we want to start at the second character. And what we want to do is compare it to the character before it. If they're the same, it's a duplicate, and we can immediately return false. So let's code that out. That's it. This function works perfectly as well. Let's run it just to make sure. Again, we're expecting true, 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 false. And that's exactly what we get. Let's go ahead and clean this up a little bit. And again, let's talk about time and space complexities. So in this case, we're starting with a sort right here. Now, different sorting algorithms have different time complexities, but in general, if we're talking about a sort, we can assume a time complexity of O of n times log of n. This here is a standard loop. It's just going to be O of n. Because these things happen sequentially, and we don't have a loop inside a loop, we can simply add these. So we're going to start with O of n times a log of n plus O of n, which turns into O of n plus n times log of n. And n is a lower order term than this right here. Let's simplify this further to show exactly what that means. When we're talking about time complexities, we can simply eliminate the lower order terms. So we can get rid of this 1 plus. And our final time complexity ends up being exactly this. O of n times log of n. And that's our time complexity for this solution. What about space? Previously it was O of 1, but now we're taking each character and we're storing it in an array. That's what happens here. So we're storing each character, meaning we take up the same amount of space as the size of the input. So it's going to be O of n. We'll talk about 2 more solutions in the next video. See you there.